Hi and welcome to the next video, locating patterns in strings and sampling large vectors. Let's start with locating patterns in strings with search and choosing the optimal implementation. So let's have a look at the entire code. We will use the new search function with strings and try its different variations with searcher objects. Now we will understand our code. First, we will include all the necessary headers and declare that we use the standard namespace. We will print substrings from the positions the search algorithm returns to us, so let's implement a little helper function for that. In the main function, a lorem ipsum style string will work as our example string, within which we will search a substring. In this case, this is elita. The search interface accepts the begin-end iterators of the string within which we are searching a specific substring, and the begin-end iterators of the substring. It then returns an iterator pointing to the substring it was able to find. If it didn't find the string, the returned iterator will be the end iterator, and the iterator will be stored in match variable. The C++17 version of search does not accept two pairs of iterators, but one pair of begin-end iterators and a searcher object. The default searcher takes the begin-end pair of iterators of the substring that we are searching for in the larger string. The point of this change is that it is easy to switch the search algorithm this way. The Boyer-Moore searcher uses the Boyer-Moore search algorithm for a faster search. The C++17 STL comes with 3 different searcher object implementations. The third one is the Boyer-Moore horsepool search algorithm implementation. Now let's compile and run our program. Go to your terminal and type in the command for compiling the code. After the successful compilation, let's execute it. This is the output we obtained. We should see the same string everywhere if it runs correctly. And here we get the string elita, same throughout. After that, let's look at sampling large vectors. The sample function does not add random alterations to sample points with fixed offset, but chooses completely random points. Therefore, it works a bit differently from the example that we just saw. Go to the atom editor, open the ex8 directory, and inside that, open the respective .cpp file. Now take a look at the entire code. We will sample a very large vector of random data. This random data shows a normal distribution. After sampling it, the resulting points should still show a normal distribution, which we will check. Let's understand the code. First, we need to include everything we use and declare that we use the standard namespace in order to spare us some typing. It is easier to play around with the code if we configure specific characteristics of our algorithm in their own constant variables. These are the size of the large random vector and the number of samples that we are going to take from it. The large randomly filled vector should get numbers from a random number generator, which gives out numbers from a normal distribution. Any normal distribution can be characterized by the mean value and the standard deviation from the mean value. Next, we set up the random generator. First, we instantiate a random device and call it once to get a seed for the constructor of a random generator. Then we instantiate a distribution object that applies normal distribution to the random output. After that, we instantiate a vector of integers and fill it with a lot of random numbers. This is achieved using the generateN algorithm, which will call a generator function object to feed its return value into our vector using a backinserter iterator. The generator function object just wraps around the D of gen expression, which gets a random number from the random device and feeds it into the distribution object. Now we instantiate another vector that will contain the much smaller set of samples. The sample algorithm works similar to copy, but it takes 2 additional parameters: the number of samples, which it shall take from the input range, and a random number generator object, which it will consult to get random sampling positions. We're already done with the sampling. The rest of the code is for displaying purposes. The input data has a normal distribution, and if the sampling algorithm works well, then the sampled vector should show a normal distribution too. To see how much of a normal distribution is left, we will print a histogram of the values. Finally, we loop over all the items in order to print our histogram. So now it's time to compile and execute the code. Go to the terminal and navigate to the ex8 directory. Next, clear the screen using the reset command. After that, type in the command for compiling the code. After the successful compilation, let's execute it. Great! This is the output we obtained. We see that the sampled vector still roughly shows the characteristics of a normal distribution. This is it for the video. In the next video, we will be generating permutations and implementing a dictionary.